Assalamualaikum and good morning. Today I, Immanuel Irfan bin Saifuddin from the BMMV class, would like to make a presentation about my research, which was the vibration analysis on the plate vein fault using frequency-based technique and verification by machine learning. The name of my supervisor is T.S. Noor Azazi bin Ngatiman. For this presentation will include the Chapter 1 Introduction, the Chapter 2 Literature Review, the Chapter 3 Methodology, the Chapter 4 Results and Discussion, and Chapter 5 the Conclusion and Recommendations. For Chapter 1 Introduction, first we'd like to introduce what is vibration. Vibration in general is a type of movement that moves back and forth periodically. Is the movement of a particle that moves back and forth periodically, and it can be described into two types, which is free and forced. Free vibration is a type of vibration that occurs naturally without external forces. An example of this will be damping. While forced vibration is a type of vibration that occurs when the system of an object has been hit by external force which causes it to vibrate. And then the problem statement. For this research, we'll check on the rotor, which is part that can easily break, and if it breaks, will affect most of the machine of the rotor. Then we'll check whether vibration analysis can be used for early fault detection and how effective is machine learning for future fault detection. The objective of this research is to obtain data of normal and fault rotor vane based on the vibration, to analyze the vibration signal obtained from the experiment using frequency-based and vibration statistical analysis, and to verify data analyzed using a machine learning technique. This is Chapter 2 Literature Review. The content of the review will include the vibration condition monitoring, rotary vane, simulation by MATLAB Simulink, the vibration signal, and for performance verification through machine learning. Vibration condition monitoring. Condition monitoring is a type of vibration analysis that is used to detect vibration in machine and component or any maintenance decision related to the machine. It is nowadays popular to be used because if normally to detect what fault can be seen, it requires high amount of cost to take apart the machine and put it back together again, while condition monitoring can be done without doing it, without taking apart. And we'll talk about the rotary vane. Rotor is a body suspended through a set of cylindrical hinges or bearings that allow it to rotate freely and exist. It can often be described as either a singular beam or a series of beam elements and rigid disk. The rotor that we'll use for this analysis, which is normal, where there's no fault or error can be seen on the rotor. Static, a singular object will be placed on the rotor. Random, which is two objects will be placed randomly on the rotor. And finally, the dynamic, which has two objects placed on the rotor directly perpendicular to each other. And we'll talk about simulation by MATLAB Simulink. MATLAB is a professional program that used specifically in technical computing. It can do various computation progress, resolution, and programming method that is easy to use, and where most of the problems are stated in mathematical notation. It can be used for math computation, algorithm development, modeling and simulation, and when used with Simulink program, it can perform multi-domain modeling and simulation that actually simulate the original parts function. Then we'll talk about the vibration analysis. Vibration analysis is a process that monitors vibration signals that are released by component, machinery, or structures. Meaning that we are use vibration analysis to detect vibration and the condition to test the object. Usually, they analyze the data that is by using time domain, frequency domain, time frequency domain, and the fast Fourier transform. This is some example of vibration analysis, which is the time domain, frequency domain, and time frequency domain analysis. For time domain, we analyze the vibration data obtained in the form of time function. For the frequency domain, we use frequencies instead of time, and the time frequency domain, we use both at the same time for vibration analysis. Then we have the fast Fourier transform. First, Fourier transform is actually an algorithm that transforms the function f that is defined either over space or time, the frequency domain. Then the fast Fourier transform is the Fourier transform calculation that was done by a computer. Then statistical analysis. Statistical analysis is the analysis of data obtained using well-described systematic and mathematical procedures and rules. The result for this analysis can only be displayed using numbers and not words. And the performance verification by machine learning. Machine learning, a type of field study that specializes in using computational algorithms and empirical data and changes to a usable model. There are many types of machine learning that can be used in the context of vibration analysis. First is the artificial neural network, which is a series of computational models that can be used for a variety of things like pattern navigation, speech synthesis, recognition, forecasting, or prediction, and many more. And then we have the support vector machine, which uses a regression method of modeling that can be used for forecasting and they determine the cause and effect relationship between variables. The other example of machine learning is that K-nearest neighbor, which is a type learning algorithm that has been made applicable to a real-life situation and be widely used in pattern identification, regression, outlier detection, and many more. And this is chapter 3 methodology. This is the experiment set up for the experiment that's done for this research. For this experiment, 5 different speed was used, which is 300 RPM, 600 RPM, 900 RPM, 1200 RPM, and 1500 RPM. Is done for 3 times and the average result will be used for the vibration analysis. For the rotor has 4 different types of setup, which is normal, where there's no fault and error can be found. Then static, where a single object will be placed on one part of the rotor. The dynamic, which has 2 objects placed on the rotor at a directly proportionate between each other, and random, where 2 objects are placed randomly on the rotor. Then the data processing and analysis be done by calculating the parameters by using the equation given, and the frequency domain analysis was done through the MATLAB Simulink. And comparison data with machine learning, which is the proper assessment and discussion was made based on how close the comparison were, probably in real world setting, and the comparison was made to detect the similarity in the accuracy, sensitivity, and specificity. This is chapter 4, results and discussion. This is the result obtained, which is the fast Fourier transform diagram. This is an example data obtained from 4 types of rotor at 300 RPM. This can we see on the static. Static has a higher amplitude when compared to normal. This means that the vibration on the static rotor is higher than the normal. This is due to the one object that was placed on the rotor which caused it to vibrate more. Then the random, which has more amplitude when compared to normal, this is because there are 2 objects on the rotor which cause it to vibrate more at a random rate, and thus has higher amount of spike in amplitude when compared to normal. And then dynamic rotor, which also has more number of spikes when compared to normal because of the 2 objects that was placed directly perpendicular to each other. And the standard deviation, was shown that under 900 RPM, a sudden spike in reading can be obtained from dynamic, normal, and random, which means that on the 900 RPM, there's a higher chance for the roller to fail because roller to fail. And in the skew, it can be seen that for the static setup, there's a further deviation on reading when compared to the other three setups. It deviated further away from the rest of the reading, especially the normal one. This meant that the static setup has the highest chance to cause vibration the rotor to something stuck on one side of the rotor. You have seen the cortices, which is the static and dynamic setup has the largest difference when compared to normal setup. In setup like cause disturbance on the instrument to the point has affected the reading, and for the static setup, the object will cause the rotor to become imbalanced while the dynamic setup will cause the rotor to vibrate faster to having extra weight stuck onto it. And then we'll talk about the machine learning. Based on the result obtained from the MATLAB, there are four type machine learning that has the highest degree of accuracy of vibration analysis, which is the SVM fine Gaussian, the fine KN, weighted KN, and the ensemble subspace KN. Based on the result obtained, this four machine learning process give the higher accuracy when compared to other type of machine learning process. The SVM process gave a 92.5% accuracy, while the other three have an accuracy of 100%. This means that this form of machine learning has the highest degree of accuracy of detecting future fault detection. And chapter 5 conclusion and recommendation. For the conclusion is used to prove that vibration analysis can be used to detect early fault detection inside an ICE. It can be used by the machine learning program to predict when a part inside the ICE will fail based on the data obtained. And the method used for the analysis of the data obtained will be effective and clear, and shows clearly what kind of fault that can lead to future failure of an ICE. And recommendation, this research can be done by using multiple rotor so that we can have data on what happens if there are multiple rotor failures, and can further be improved by increasing the number of data obtained so that higher accuracy results can be obtained. And finally, by improving the quality of sensors, meaning by having sensors that have high sensitivity, you can even detect the smallest vibration have occurred. Thank you.